wanted to make some last comments about polynomial regression. Polynomial regression is just a nice example of using multiple regression on a data set which just has a y and an x value. I just want to say that using multiple regression has a lot of applications beyond just fitting data curves, with each one being what we say linear. And we'll say a little bit more about this in the coming days. However, let me just make the last few comments here. The first one is that, again, as always, avoid extrapolation. Do not extrapolate beyond the limits of your observed values, particularly when the polynomial function has pronounced curve. Such extrapolation produces meaningless results about the scope of the data. What that means is, suppose your x values go between 5 and 15 years. Do not extrapolate out to 30 years. The model does not work as well in that situation. And again, as always, residual analysis is very important, and you can only make it if the assumptions of the model are reasonable. And you must do residual analysis to determine if the assumption is reasonable, and particularly for polynomial regression, determine if there are curves or other sorts of things that are going on that you may use a higher degree term or a lower degree term. A variety of areas, just a reminder that residual analysis and avoiding extrapolation are important for any multiple regression model that you look at, and should keep that in mind. If you do include a higher degree term, include all lower degree terms. That is, if you include the big brother, you got to take the little sister and little brother along with you. So if you include x to the third, you must include the x squared and x values. And because of that, you should not go strictly by low p-values for higher degree terms. And you should use these models, or use these predictors to support your model only if the resulting residual plots look reasonable. And again, this is an example where you need to determine practical significance versus statistical significance. One of the challenges of statistics at this level and beyond is that there's no hard and fast rule. You have to use your judgment, and that judgment comes from a good understanding of the theory and a good experience with the data. And just some other common things. The fitted model is more reliable when built upon a larger sample size n. The more data that you sample, and sampled well, a good simple random sample, for example, the better the model will be. And one other minor point is, like, if you have x values that are like $100,000, when you square it and cube it, you get such huge numbers that the computer may not handle it. And that's kind of what I ran into when I was trying to predict or use the housing price to predict something else. So you might want to rescale and make that like 1.3 hundred-thousandth of dollars or something like that. But the big key takeaway is using the ideas of multiple regression linear models can be extended to a variety of areas. Now, just because I am filming this after Easter, and this doesn't have to do with multiple regression as much. These were just my last comments, but let's just kind of see what Jesus' last comments were. Jesus' last comments were, at least in Matthew, "Go therefore and make disciples of all nations, baptizing in the name of the Father and the Son and the Holy Spirit, teaching them to observe all that I have commanded you. And lo, I am with you always to the close of the age." I am not with you, lo, always to the close of age, but I would like you to observe at least my teachings. But I would definitely like you to observe Jesus' teaching and all that he has said. All right.